Hello guys, welcome to our YouTube channel. Today we are going to learn about following topics. C language basic syntax rules, variables, data types, keywords, operators, comments, format specifier, escape sequence, constants, errors, tokens in C. C language syntax specify rules for sequence of characters to be written in C language. In simple language it states how to form statements in a C language program, how should the line of code start, how it should end, where to use double quotes, where to use curly brackets, etc. So C tokens are basically the building blocks of a C program. Semicolon is used to mark the end of a statement and beginning of another statement. Absence of semicolon at the end of any statement will mislead the compiler to think that this statement is not yet finished and it will add the next consecutive statement after it, which may lead to compilation syntax error. In the above program, we have omitted the semicolon from the printf statement, hence the compiler will think that starting from printf up till the semicolon after return 0 statement is a single statement and this will lead to compilation error. Comments are plain simple text in a C program that are not compiled by the compiler. We write comments for better understanding of the program. Though writing comments is not compulsory, but it is recommended to make your program more descriptive. It make the code more readable. There are two ways in which we can write comments. Using this is used to write a single line comment. Using asterisk asterisk, the statements enclosed within asterisk and asterisk are used to write multi-line comments. Types of comments: 1. Single line comments. 2. Multi-line comments. Some basic syntax rule for C program. C is a case-sensitive language, so all C instructions must be written in lowercase letter. All C statement must end with a semicolon. Whitespace is used in C to describe blanks and tabs. Whitespace is required between keywords and identifiers. A variable is nothing but a name given to a storage area that our programs can manipulate. Each variable in C has a specific type, which determines the size and layout of the variable's memory, the range of values that can be stored within that memory, and the set of operations that can be applied to the variable. The name of a variable can be composed of letters, digits, and the underscore character. It must begin with either a letter or an underscore. Upper and lowercase letters are distinct because C is case-sensitive. Jar typically a single octet, 1 byte. It is an integer type. Int the most natural size of integer for the machine. Float a single precision floating point value. Double a double precision floating point value. Void represents the absence of type. C programming language also allows to define various other types of variables, which we will cover in subsequent chapters like enumeration, pointer, array, structure, union, etc. For this chapter, let us study only basic variable types. Variable definition in C. A variable definition tells the compiler where and how much storage to create for the variable. Rules for defining variables. A variable can have alphabets, digits, and underscore. A variable name can start with the alphabet and underscore only. It can't start with a digit. No whitespace is allowed within the variable name. A variable name must not be any reserved word or keyword, e.g. int, float, etc. Types of variables in C. There are many types of variables in C. Local variable. A variable that is declared inside the function or block is called a local variable. It must be declared at the start of the block. You must have to initialize the local variable before it is used. Global variable. A variable that is declared outside the function or block is called a global variable. Any function can change the value of the global variable. It is available to all the functions. It must be declared at the start of the block. Static variable. A variable that is declared with the static keyword is called static variable. It retains its value between multiple function calls. If you call this function many times, the local variable will print the same value for each function call, e.g., 11, 11, 11 and so on. But the static variable will print the incremented value in each function call, e.g. 11, 12, 13 and so on. Automatic variable. All variables in C that are declared inside the block are automatic variables by default. We can explicitly declare an automatic variable using auto keyword. Data types in C. A data type specifies the type of data that a variable can store, such as integer, floating, character, etc. There are the following data types in C language. Basic data types. Each variable in C has an associated data type. Each data type requires different amounts of memory and has some specific operations which can be performed over it. Let us briefly describe them one by one. Following are the examples of some very common data types used in C. Char, the most basic data type in C. It stores a single character and requires a single byte of memory in almost all compilers. Int, as the name suggests, an int variable is used to store an integer. Float, it is used to store decimal numbers with floating point value, with single precision. Double, it is used to store decimal numbers with floating point value, with double precision. Different data types also have different ranges up to which they can store numbers. These ranges may vary from compiler to compiler. The basic data types are integer-based and floating point-based. C language supports both signed and unsigned literals. The memory size of the basic data types may change according to 32 or 64-bit operating system. Let's see the basic data types. Its size is given according to 32-bit architecture. Derived data types. The data types that are derived from the primitive or built-in data types are referred to as derived data types. These can be of four types, namely, function, array, pointers, references. Let's briefly understand each of the following derived data types. Function. A function is a block of code or program segment that is defined to perform a specific well-defined task. A function is generally defined to save the user from writing the same lines of code again and again for the same input. All the lines of code are put together inside a single function, and this can be called anywhere required. Main is a default function that is defined in every program of C++. Array. An array is a collection of items stored at continuous memory locations. The idea of array is to represent many instances in one variable. Pointers. Pointers are symbolic representation of addresses. They enable programs to simulate call by reference as well as to create and manipulate dynamic data structures. Reference. When a variable is declared as reference, it becomes an alternative name for an existing variable. A variable can be declared as reference by putting and in the declaration enumeration, or enum, in C. Enumeration, or enum, is a user-defined data type in C. It is mainly used to assign names to integral constants. The names make a program easy to read and maintain. The keyword, enum, is used to declare new enumeration types in C and C++. The void type, in several programming languages derived from C and ALGOL 68, is the type for the result of a function that returns normally, but does not provide a result value to its caller. Usually such functions are called for their side effects, such as performing some task or writing to their output parameters. Keywords are specific reserved words in C, each of which has a specific feature associated with it. Almost all of the words which help us use the functionality of the C language are included in the list of keywords. The list of keywords is as follows. Auto. The auto keyword declares automatic variables. Break and continue. The break statement terminates the innermost loop immediately when it's encountered. It's also used to terminate the switch statement. The continue statement skips the statements after it inside the loop for the iteration. Switch. Case and default. The switch and case statement is used when a block of statements has to be executed among many blocks. Char. The char keyword declares a character variable. Const. An identifier can be declared constant by using the const keyword. Double and float keywords. Double and float are used for declaring floating type variables. If and else. In C programming, if and else are used to make decisions. Enum. Enumeration types are declared in C programming using keyword enum. Extern. The extern keyword declares that a variable or a function has external linkage outside of the file it is declared. Goto. The goto statement is used to transfer control of the program to the specified label. Int. The int keyword is used to declare integer type variables. Short, long, signed and unsigned. The short, long, signed and unsigned keywords are type modifiers that alter the meaning of a base data type to yield a new type. Return. The return keyword terminates the function and returns the value. Size of. The size of keyword evaluates the size of data, a variable or a constant. Register. The register keyword creates register variables which are much faster than normal variables. Struct. The struct keyword is used for declaring a structure. A structure can hold variables of different types under a single name. Typedef. The typedef keyword is used to explicitly associate a type with an identifier. Union. A union is used for grouping different types of variables under a single name. Volatile. The volatile keyword is used for creating volatile objects. A volatile object can be modified in an unspecified way by the hardware. Operators are the foundation of any programming language. Thus, the functionality of C programming language is incomplete without the use of operators. We can define operators as symbols that help us to perform specific mathematical and logical computations on operands. In other words, we can say that an operator operates the operands. For example, consider the below statement. C equals A plus B. Here, plus is the operator known as addition operator and A and B are operands. The addition operator tells the compiler to add both of the operands, A and B. C has many built-in operator types and they are classified as follows: arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, MESC operators. So, let's understand briefly. Arithmetic operators. These are the operators used to perform arithmetic mathematical operations on operands. Examples: plus, minus, etc. Arithmetic operator are of two types: unary operators. Operators that operates or works with a single operand are unary operators. For example, plus plus, minus. Binary operators. Operators that operates or works with two operands are binary operators. For example, plus, minus, multiplication, division. Relational operators. These are used for comparison of the values of two operands. For example, checking if one operand is equal to the other operand or not, an operand is greater than the other operand or not, etc. Some of the relational operators are equals equals, greater than equals, less than equals. Logical operators. Logical operators are used to combine two or more conditions, constraints, or to complement the evaluation of the original condition in consideration. The result of the operation of a logical operator is a Boolean value, either true or false. For example, the logical and represented as and operator in C or C++ returns true when both the conditions under consideration are satisfied. Otherwise, it returns false. Therefore, A and B returns true when both A and B are true, i.e. non-zero. Bitwise operators. The bitwise operators is used to perform bit-level operations on the operands. The operators are first converted to bit level and then the calculation is performed on the operands. The mathematical operations such as addition, subtraction, multiplication, etc. can be performed at bit level for faster processing. For example, the bitwise and represented as an operator in C or C++ takes two numbers as operands and does an on every bit of two numbers. The result of and is 1 only if both bits are 1. Assignment operators. Assignment operators are used to assign value to a variable. The left side operand of the assignment operator is a variable and right side operand of the assignment operator is a value. The value on the right side must be of the same data type of variable on the left side, otherwise the compiler will raise an error. Different types of assignment operators are shown below. Equals. This is the simplest assignment operator. This operator is used to assign the value on the right to the variable on the left. For example, A equals 10, B equals 20, CH equals Y. Plus equals. This operator is combination of plus and equals operators. This operator first adds the current value of the variable on left to the value on right and then assigns the result to the variable on the left. Example: sad face A plus equals B can be written as A equals A plus B. If initially value stored in A is 5, then A plus equals 6 equals 11. Equals. This operator is combination of and equals operators. This operator first subtracts the value on right from the current value of the variable on left and then assigns the result to the variable on the left. Example: sad face A equals B can be written as A equals A, B. If initially value stored in A is 8, then A equals 6 equals 2. Asterisk equals. This operator is combination of asterisk and equals operators. This operator first multiplies the current value of the variable on left to the value on right and then assigns the result to the variable on the left. Example: sad face A asterisk equals B can be written as A equals A asterisk B. If initially value stored in A is 5, then A asterisk equals 6 equals 30. Equals. This operator is combination of and equals operators. This operator first divides the current value of the variable on left by the value on right and then assigns the result to the variable on the left. Example: sad face A equals B can be written as A equals A, B. If initially value stored in A is 6, then A equals 2 equals 3. Other operators. Apart from the above operators, there are some other operators available in C or C++ used to perform some specific task. Some of them are discussed here. Sizeof operator. Sizeof is a much used in the C, C++ programming language. It is a compile-time unary operator which can be used to compute the size of its operand. The result of size of is of unsigned integral type which is usually denoted by size_t. Basically, size of operator is used to compute the size of the variable. Comma operator. The comma operator, represented by the token, is a binary operator that evaluates its first operand and discards the result. It then evaluates the second operand and returns this value, and type. The comma operator has the lowest precedence of any C operator. Comma acts as both operator and separator. Conditional operator. Conditional operator is of the form expression 1, expression 2, expression 3. Here, expression 1 is the condition to be evaluated. If the condition expression 1 is true, then we will execute and return the result of expression 2. Otherwise, if the condition expression 1 is false, then we will execute and return the result of expression 3. We may replace the use of if, else statements by conditional operators.